Welcome to a session on descriptive statistics, where we're going to learn grouped data to look at the measures of central tendency, starting from the mean, the mode, and also to calculate the median. We'll also look at how to come up with the quartiles and also illustrate how to do the box-whisker plot. So whenever data is put in groups, we call that grouped data. So this is the frequency distribution table, which has what we call the classes and the frequency here. Now, from the classes, you're able to tell three things. Number one, whether this data is adjusted or not. 280 to 283, 284 to 287, 288, so there's a gap of 1. So this is telling you that they are not adjusted. Number one, the data is presented in terms of a bar chart. Number two, and we are also able to establish our class width. Our class width for the unadjusted data is by finding the differences in the boundaries. So this bound here you're seeing here is called the lower boundary. The lower boundary or the lower boundary are these figures aside. Yeah, the upper boundaries are these figures on this. So lower boundary, upper boundary. The differences between the boundaries will give you the height or the width. So our width from this data set, we are able to tell our height is what? 4. So the distance from 280 to 284 is 4. 284 to 288 is 4. But if you subtract from this figure to that figure, it will give you a 3, which is a wrong answer because this data is not adjusted. So it's always safer at all costs to get the height from one strand, either on the upper bound or the lower bound. The frequency this side is just telling you the distributions, how many figures we have between this interval. We have 2, 8, 14, 14, 5, and 2. So we can find the midpoint of the frequency by adding the lower bound and adding the upper bound dividing by 2. So lower bound plus upper bound, we divide by 2. We call that the midpoint. This is the midpoint. So 280 plus 283 divided by 2 gets 281.5. 284 plus 287 divided by 2, 285.5. Until the last one, we get 301.5. So this is how we find our midpoint. Are we clear on the midpoint? Is there anyone behind? So the midpoint is called X, not X bar, it's just a midpoint. When we apply the midpoint plus a frequency, it will help us find what we call the median, the mean, sorry. So in this case here, we're going to multiply the midpoint, the frequency. So we're going to get the f of x. And the mean for group data is simply given by the sum of f of x divided by the frequency of f. Our frequency of f, the sum of the frequency of f is also called n. So the formula for group data can be summation of the frequency divided by n. So you multiply this times that, this times that, this times that, then over the total here. If you want, you can just multiply this by that, this by that, this by that, over the sum total of the frequency, which is 45. So this is what we call our approximate mean score. Can somebody tell me how do you find the approximate mean score here again? Identify the midpoint. Add the lower and the upper bound. This is called the midpoint. And this is our frequency. You can multiply these two and total up. So the midpoint here, 22, is found by adding 20 plus 24 divided by 2 to get 22. Then you multiply these figures here. Then you divide by the number of frequencies here from 8 up to 10. So this will give us a total of 155. When we apply this one by that, we get the frequency of f of x. So the 16 carry 1, 17. And you add the last number, 10 by 47 is 470. Then when you total up here, the total figure you're going to get is 53.55. So when you divide this divided by that, this is called the summation of what? The frequency x divided by summation of what? F. So 53.55 divided by what? 155. All right, so I'm starting with what you already know to what you don't know. So what we get is called our mean. So the mean age here is 34.5. 34.5. All right. The same appears here where we have the frequencies, find the midpoint, multiply by the frequencies over the total sum of the frequencies. We find that. So this is what we call our mean for group data. So I don't know whatever happens in the exam when you forget, okay. So I'm going to use that, all right, to calculate our question number 1. Most people did not perform well in this previous exam. Most of the questions will be predominant in your first test as well. So I need to at least explain the key principles so that you understand. So the midpoint, whether it is the 3 and under 3.2, 3.2 and under, you simply add this figure and that figure divided by 2. Multiply the 2 to get the frequency sum of the fx divided by n. So is there anyone behind in calculating our mean using group data? Is there anyone behind in calculating the mean using our group data? Then we also have another measure of what? Central tendency, or measure of dispersion, which is called the range. The range is simply the difference between the highest number and the smallest number. Our highest number is 1075. Our lowest number is 485. The range is called what? Our 590 is our range. But when we add the highest number plus the smallest number divided by 2, we call that the mid-range. The mid-range. I think that's what we're doing in the morning. All right, so the range is simply the highest number and smallest number. Also in integers, the highest number on the negative is the smallest number. So the highest number here is -2. The smallest number here is -25. So we'll add this -2 minus -25. So from our grade 5, remember that negative and negative become positive. So this negative becomes a positive there. Then range here will be negative what? Negative positive 23, because this will be -2 plus 25. So a range will always be positive. You can never get a negative range because it's the difference between the highest number and the smallest number. So never get a negative, it's always a positive value. All right. So this is how we find the range. The range is simply the difference. Then we have what are called quartiles. Using our index method, we have 3 quartiles. We have what we call the first quartile, which is the 25th percentile, or a quarter. We have the second quartile, which is called the 50th percentile, or half. We have the third quartile, which is called the 75th percentile, or 3/4, which is 75%. So these are called the quartiles. The quartiles are found firstly by having to rearrange your data in order, ascending order, then calculating the position based on the figures that you have. So in this case, we are going to calculate our percentiles based on this data here. Fortunately, it's already rearranged, but you need to always rearrange them. So the 25th percentile is the first quartile, or a quarter is simply 25%. So a quarter of n. Now, I need you to understand that if we're dealing with numbers, any decimal you round up, any full number, you add that number, and you add the second number. Then you divide by what? By 2. So let's start with such numbers. Let's see. If we have 9 elements, how do you find the first quarter? It's a quarter of 9. Yeah. A quarter of 9. What we get? We get 2.25. So since there's a decimal point here, the position that you're going to get is the third position. On this very 9, if we got our second quarter, which is the median, half of 9, we're going to get 4.5. Because it's a decimal point, we always round up. So what position are we going to look at here? The 5th position. If we get the upper quarter, which is 3/4 of 9. 3/4 of 9. What do we get? We get 6.75. Round off, as long as it's a point, whether it's a smaller number, don't use the nearest, because look here, it is 2.2. Then you round off the nearest is 2. No. You round up. So this is 7th position. These are just positions, they're not figures. This is based on the sample size of what? Of 9. But if we're basing it on the sample size of 10, the first quarter will be what? A quarter of 10. Well, let me use 12, sorry, just for argument's sake. 12. The first quarter, we're going to get what? The third position. So what does this mean? You're picking the third number and the fourth number. You divide by what? By 2. I think this is where the trick part is for most of you. The second quarter, so we're going to half of 12, which is what? 6. What does this mean if you're picking position 6? The 6th and the what? And the 7th, right? Divide by what? By 2. And third quarter, it is 3/4 of what? 12. So 3/4 of 12, we're going to get the 9th position. 9th position means what? Don't get the 9th position, get the 9th and the what? The 10th position divided by 2. Anyone behind on how to identify the quarters? Please ask now, or forever hold your peace.
Mr. Collins.
Yes, sir.
Sorry, I'm a bit behind. I was kicked out. I think I lost connection. So I'm a bit behind basically on the quartiles.
So
maybe you can start from, yes.
So quartiles basically give you the position of the figure you're looking for. So firstly, I started by explaining to say, if you find an answer like 2.1, in fact, if you find a continuous variable, okay, 2.7, 2.8, to find the position of this one, you round up. This is just the third position you're looking for. All right. This is the third position. But if your answer is what? Exactly 2. This means that you find n plus 1. The 2 plus the 3, you add them and you divide by what? By 2. That is how it goes. If you find the answer exactly 5, what does this mean? You get the 5th number and the number that follows it, the 6th number. You add them and divide by what? By 2. That is the rule. So for quartiles, we said the first thing you need to do is to rearrange your data. So if you had numbers like this 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So these are the figures that we have there. So from what I've already explained so far, we can identify our range as being what? The difference between the highest number and the smallest number. Our range in this case is what? 20 minus what? 2. What we get? 18. That is called our range. Our mid-range is found by what? Adding the 2. 20 plus what? 2 divided by 2. What do we get? 11. All right. Our mode is the figure that appears the most there. What figure appears the most? The 6. So this is how we find these figures there. Then 1, 2, 3, 4, 5, 6, 7. Our n is 7. So we can find the 3 quartiles. We have quartile 1. Quartile 1 is called the lower quartile or the first quartile. It is simply found by a quarter of n. Don't put n plus 1, just n. So our n here is what? 7. Whenever there's a decimal, you round up. Already our data is arranged in order. Do not always be. So what are we going to get here? We're going to get 1.75. So this means that we're looking for position number what? Second position. So meaning our second position in this case, when you look at the data set you have there, we have 1, 2, 3, 4, 5, 6, 7. Second position there is what? 4. So the 4th number there. Who can help us find our second quartile? What is the formula for the second quartile?
So where is your beans?
For the second quarter, simply half of n.
Half of n. Okay, so our n is what?
N is 20.
N is 7.
Oh, sorry, 7.
So half of 7 is what?
3.5.
So 3.5. Which position are we getting?
Number 4.
The fourth position.
Good. 4th position. So which one is the 4th position?
6.
6. Good. So the value of the second quartile is 6. The second quartile, the other name is called what?
That's the median.
That's the median, correct. It's called the median. Then we have the third quartile, which is given by what?
3/4 of n.
Okay, 3/4 of n. What do we get?
And that's 21 divided by 4. We're
Mhm.
talking of 5.2.
5.225. So what position are we looking at?
Number 6, which is 10.
60th position, which is 10. Now, see who are we following?
Yes, I am.
All right. So if we have found the 60th position, which is 10, then we can find the range of the quartiles. The range of the quartiles has a special name. What is the special name for the range of the quartiles?
Interquartile range.
Good. Interquartile range. Interquartile range is simply the difference between the highest quartile, which is Q3, minus the lowest quartile, which is Q1. So here we're going to have 10 minus what?
Minus 4.
Which is what? Which is
Which is 6.
right. So that is called the interquartile range. The semiquartile range is simply half of the interquartile range. So if we're going to half this interquartile range, we're going to get a half of 6, which is what? 3. Although I don't mind this so much, it's never asked, but just for your own information. All right, so anyone behind so far? All right, so I'm teaching like I'm teaching BIDs for now. I hope we are all together. There's a box which looks like this. What is this box called? What is this box called?
See the box and whisker.
The box and whisker plot. It is able to identify the outliers. So it has the smallest values, which is 2, and the highest values, which is 20. It also has 4, 6, 10, which helps us identify our quartiles. The interquartile range we found as a difference between the highest quartile and the what? The lowest quartile. This was 10 minus 4, we found 6. Then when you apply 1.5 to the interquartile range, the 1.5 is a standard figure. So 1.5 times 6, we get a 9. This is a correction term. So the 9, we add it here to the upper quartile. Then you subtract it here from the lower quartile. So 6 is the interquartile range. You multiply times 1.5 to get the extreme values. 1.5 times 6, we get the 9. Where's 1.5 coming from? It is part of the formulas you find in the notes that when you're finding the extreme lower value, it is Q1, 1 IQR. Finding the upper values, it is Q3 plus 1.5 IQR. So this 1.5 IQR is a correction term. So I'm simplifying your work just to say multiply times the interquartile range, then quickly add 9 plus 10, it's 19. You close there, this is the extreme value here. Then 6, we subtract from 4, we get -2. We close there. Any figures outside there are called what? Outliers. So this side, there are no figures. This side, there's one figure, which is 20. So 20 is going to be called an outlier. So this is how we draw the box whisker plot. This is how we draw what we call the box whisker plot. Any questions so far before we proceed? Are we all together? All right.
Mr. Where did we get the 9 from?
Where did we get the 9? Somebody has a question there. Where did we get the 9?
I know the 6 is the interquartile range.
We multiplied
Uh,
the interquartile range by 1.5, which gives us 9.
We're saying we multiply.
All right. Okay, thank you.
Now, where's the 1.5? You're not asking where the 1.5 is coming from.
No, I know that is the standard, the 1.5.
The standard figure, correct.
Yes.
Okay. I'm glad you're following. Any other questions so far?
How did you find the negative 2?
How do you find the negative 2? There's another question there. Somebody to answer? How do you find the 19
Yes,
negative 2?
the 19 is that since with the interquartile range is equals to 9, then there we are saying the interquartile range. I hope I'm not mixing. Okay, yeah. So it's the 19 is Q3 plus the 9. And Q3 we found 10. Then similarly for the negative 2, we are saying Q1 minus 9. That's how we are finding negative 2. So the key is the interquartile range by 1.5. Then the number you find, you do plus Q3 or minus Q1. Or you say Q1 minus the number you find, or Q3 plus the number you find.
Is that clear?
Okay.
All right, thank you for that. So after we find the 9, on this number, just add it. We get 19. On this number, just subtract 4 minus that, negative 2. Any numbers outside there, outlier, so your range will be negative 2, 19. So identify any numbers that are outside that range. We say those are outliers.
So it's negative 5.
All right, can I proceed? Allow me to proceed.
Mr. Collins, sorry. How is 4 minus 9 negative 2? Sorry, isn't it supposed to be 5 or something?
I was waiting for that. Anyway,
I'm also finding 5.
5. It was just a calculation error. It's
Yeah.
actually, thank you for that. All right, so the range is actually negative 5, comma what? 19. Thank you. All right, so I think we've now clarified. We can go now to this question just discussed. This question is repeated 3 times. The following shows 15 houses in a particular area to be sold. So let us calculate the interquartile range and identify any outliers. So already these ones are already arranged in order. So find Q1. Q1 is a quarter of 15. So a quarter of 15 is what? 3.75. So we're going to round up. Which number we're going to look at? The 4th position. So 1, 2, 3, 4. So 36. All right, together. Then we go to Q2 is what? Q3 is 3/4 of 15. So 3/4 of 15, we get 11.25, which we round up, which is the 12th position. So 12th position is 4, 5, 6, 7, 8, 9, 10, 11, 12, 64. So that's a 64 here. The difference between 64 and 36 is called the interquartile range. So we get 28 days. The 28 days will be what? Our extra. So we have here the 9 and 115. So 9 comes here, 115 comes there. The lower quartile is 36, then 64. The difference is 28. Then 28 we multiply by 1.5 to get the correction term, which is 42. So 42, we add it here, 42 subtract it there. So when we subtract there, we get -6 as a lower value. When we add it, we're going to get 106, which is somewhere there, 106. So these are the figures. These are called the extreme values. So the lower limit, 1 minus 1.5 IQR is -6. The upper limit, it's 64 plus 42, we get 106. So any numbers between or outside that, so our coordinates or range is between -6, 106. So you identify in here, -6 and 106, only this one stands out. So the 115 is going to be considered as our outlier. Why? Because it's greater than the upper limit. Is that clear? Anyone behind? Okay, same with any questions that may come. Identify any outliers when you're given the number of minutes for 18 randomly selected flights. So you get to calculate our first quarter is a quarter of 18. 18, we get 4.5. The nearest is what? The fifth number. So if you arrange them in order, that is 1, 2, 3, 4, 5. So the fifth number is -4. Then you do 3/4 of 18, which is what? 13.5, which is the 14th number. The 14th position is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, so 20. All right. So already we have the lowest value here is what? -42. The highest value is what? 64. The Q1 and Q2 and Q3. Because these are the important ones, Q1 and Q3. Q1 is -4, Q3 is 20. When you subtract 20 minus that, so our interquartile range will be adding these two figures, which is 24. Because the difference between here, 20 minus, this becomes a plus, so we're going to get 24. Then 24, you multiply by 1.5, we get the correction term, which is 36. So the 36, we're going to add it here. When you add 36 here, it's going to be 56. When you subtract 36, -4 minus 36 is -40. -40. So any figures outside -40 and 56 are called outliers. So 42 seems to be an outlier, and also 56. Which numbers are above 56? The 61 and 64. So 61 and 64 is an outlier. Also, negative 42 is an outlier because it's less than negative 40. So all these outliers, it's not always that we find one. These are figures that are outside range, right? So that is how we find the outliers. So the principle is the same throughout in identifying outliers. This is what you do. All right, so this was a test for August last year for the distance students. We are given information like this. Number one, calculate the sample mean. Sample mean simply adding all these figures, dividing by the number of observations, 20. Calculate the standard deviation. Standard deviation has its own formula. So you first find the variance for the sample, summation of x squared over summation of x to the power 2 divided by n, everything over n minus 1. I taught you how to use a calculator just last week during the physical classes. The answer you get, if for instance you get a 16, square root of 16 is called your standard deviation. The square root of 16 is 4. So this is how you find the standard deviation. The median, who remembers how to find the median? Median is the second quarter, half of n. N is 20, so half of 20 is 10. So 10 is a whole number, so pick the 10th and the 11th number. So when you go there and you average them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So 19 and 20, when you add them, divided by 2, you're going to get 19.5. So this is how you find our what? Our median. The interquartile range is simply the difference between the upper quartile and the lower quartile. So the lower quartile, in this case, will be what? A quarter of n. Quarter of 20 is 5. So the 5th and the 6th number. 1, 2, 3, 4, 5, and 6. That number is in between, there's a 10. So 10 is our what? Our lower quartile. The upper quartile is 3/4 of what? N. So our n is 20. 20, 3/4 of 20 is what? 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So 15 and 16, since we found 15, it's a whole number. You get the next number, 16th, then you add and divide by 2. So when you divide these ones, we're going to get 59 divided by 2, which is equal to 29.5. So this is how we find the upper quartile. But that is not the answer yet. The interquartile range is the difference between the upper quartile and the lower quartile. Then you divide, you subtract the 2. 9.5 minus 10, which is 19.5. These marks here will give you only about 9 marks. For the exam, usually I don't like this because it eats up a lot of your time. Probability may be even better. Regression, ANOVA. So those who booked for the classes before the exams, I'll give you 4 topics to concentrate on so much. But for now, for the test, it's answer or. Answer any or, there's no option. So I need you to understand everything, you can't specialize. So I might include, I know today is QM only. Tomorrow is managerial economics. I might squeeze in another class on Friday, I think, for QM, just to prepare you for the test, if that is fine. But basically, I'll send the video for what we covered in the morning. There are a lot of profound things that I discussed, of course, at a very slow rate. The sample data distribution has a mode which is positively skewed, etc. State the largest of these. So you also need to understand some of the theoretical part. Most of you want to think it is only about calculations, so get to understand the theoretical part. Let's discuss. I've sent you homework. You try it. I only respond to those ones who try. Those ones who are new as usual can inbox 0977 620722 on how to join our groups. So we end here for now. Have a great day.